Hi, future doctors. So we stopped with Poiseuille. So what is the dimension formula for poise or Poiseuille? Now poise is the unit for coefficient of viscosity. Now what is the equation for coefficient of viscosity? You should get idea. Equation or unit. Poiseuille is unit. In another form also it will be available. Now we will see where we will get this coefficient of viscosity. So you will get viscous force Fv is equal to neta A dV by dx. So what is this dV by dx? For this also you will get one dimensional formula. What is dV by dx means? We will see. V means velocity, dx means distance. If velocity is changing with respect to distance, this is called velocity gradient. If velocity is changing with respect to distance, you will get in fluid mechanics this one. Change in velocity with respect to distance is called velocity gradient. Change in potential with respect to distance we will call potential gradient. So change in temperature with respect to distance is called temperature gradient. So change in pressure with respect to distance is called pressure gradient. If you people are changing with respect to distance, whenever exam is coming, if you people are changing with respect to distance, so then that is your gradient. Which is changing with respect to distance, that is that gradient we can say. Now we will say velocity is changing with respect to distance. What was the velocity dimension formula we said? L t power minus 1. This is distance we said, therefore L. Therefore, t power minus 1 is the dimensional formula for velocity gradient. Now we will see potential gradient. We said what was the potential dimensional formula. I told you we cannot remember potential dimension formula. So therefore we have to write like this. Potential V is equal to W by Q, work done by charge. What is work done dimension formula? M L square T power minus 2 by charge is AT. So M L square T power minus 2, T power minus 1, A power minus 1. So M L square T power minus 3, A power minus 1. So change in potential with respect to distance, that is going to be L. So one L will be cancelled. Therefore M L T power minus 3, A power minus 1. This is the dimension formula for potential gradient. Now temperature gradient. What is the temperature gradient we said? Change in temperature with respect to distance. So temperature we denoted either theta or K. So K by L. So L power minus 1 K. So pressure gradient. What is the pressure dimension formula? M L power minus 1 T power minus 2 by L. So M L power minus 2 T power minus 2. Isn't it? So like this we can write. So our main isn't this one. We should not forget. So we wrote because of this velocity gradient, we got these many dimensional formulas, isn't it? So we want for this coefficient of viscosity. So we got now velocity gradient. Another formula for this, Stokes law you will get 6 pi neta RV velocity. So from this also you will get coefficient of viscosity. So from this you will get little bit easily. Coefficient of viscosity is viscous force by radius velocity. What is force dimensional formula? mLt power minus 2. Radius means distance, that is L. Velocity means Lt power minus 1. Now what is the dimension formula for this one means m L power minus 1. If it is going to numerator t, therefore m L power minus 1 t power minus 1. This is the dimension formula for coefficient of viscosity. Now will you get same thing from this? We will see. So from this, coefficient of viscosity equal to Fv by viscous force by area into dV by dx. Viscous force mLt power minus 2. Area L square. What is dV by dx we got? dV by dx is t power minus 1. send it to numerator. 1 L will be cancelled. So m L power minus 1 T power minus 1. So therefore, both are going to be same. This is the dimension formula for coefficient of viscosity. Now see how they will ask problems on these dimensional formulas. So force dimension formula, F is equal to mL T power minus 2. Work I am taking, work dimensional formula, mL square T power minus 2. Okay. Now see how we are going to get the questions from this dimensional formulas. If you know one problem, you can do so many number of problems by using this. So what is the ratio of dimension of mass and length? What is the ratio of dimension of mass and length in force, they will ask. What is the ratio of dimension of mass and length in force dimension? Now for that, you people should come to know m power how much will be coming. So m power how much is there here? 1. So L power how much is there? 1. So now 1 is the dimension of mass, 1 is the dimension of length, where in force. Therefore your answer will be 1 by 1. Same question, if they asked ratio of dimension of mass and length in work, at that time your answer will be, you people can say no directly. So m by L in work, how much it will be? So mass power how much is there? 1. L power how much is there? 2. Therefore 1 is to 2. Isn't it? So like this you people should do. So like this they are going to ask. Here in this we have done ratio of dimension of mass and length. Now what is the ratio of dimension of mass and time in force? Then m power how much? 1. T power how much? Minus 2. Therefore minus 1 by 2. Same question if they ask in work. What is the ratio of dimension of mass and time in work? At the time, so m power 1 is there, T power minus 2. So these two are going to be coming same answers. Now you can create your own question like this. Now I have done here mass and length. Now same question I am asking, ratio of dimension of mass and length for velocity. Whenever they are asking velocity, what is the velocity dimension formula, you people should come to know. Velocity dimension formula is L T power minus 1. In this there is no m. Whenever there was no m means m power 0, L T power minus 1. Now what is the dimension of mass? Dimension of mass is 0. 0 by dimension of length is 1. So 0 by anything is going to become 0. Now same question if they ask reverse. What is the ratio of dimension of length and mass in velocity? Now see the questions how they are going to ask. Ratio of dimension of mass and length. Ratio of dimension of length and mass. What is the length dimension in this velocity? 1. Mass dimension we said 0. Therefore anything by 0 is going to be infinity. So these you will be getting in your 10th class. This is not related for physics. These are mathematics related. Physics related is only dimensional formula. Now you can create one question by yourself, anyone, whichever dimensional formula you are going to get. So from that you have to solve like this. Ratio of dimension of length and time. Ratio of dimension of length and time in velocity. Then in velocity length power 1, T power minus 1. Therefore minus 1 is to 1. So like this we can do n number of problems till you got the irritation on this problem. You have to practice. Then if this type of model came means definitely you are going to solve in exam. So they will give one physical quantity. So physical quantity, so m power x, L power y, T power z. So what is the ratio of dimension of mass and length means simply x by y. Ratio of dimension of mass and length. Whichever they are asking, that physical quantity dimensional formula first you people should come to know. Otherwise, you cannot solve the problem. Now, whichever one new question which we didn't cover in these videos, I am going to give. Once we can see and try. What is the ratio of, same question, what is the ratio of dimension of mass and length in power of lengths? In power of lengths, ratio of dimension of mass and length they are asking. So first you people should come to know power of lengths dimensional formula. So what is power of lengths definition? Power of lengths P is equal to, you people came to know means directly you can say, because this is second year related, even in your 10th class also in optics lesson you will get. Power is nothing but reciprocal of focal length. So focal length unit centimeter. Therefore, focal length dimensional formula is going to be L. 1 by L is nothing but L power minus 1. This is the power of the lens. Some people will get confused. Power of lens means power formula they will write. Power is equal to work by time. So lens formula is not this one. Okay. So L power minus 1. If you write fully M power 0, L power minus 1, T power 0. Correct? Now here they asked ratio of dimension of mass and length. Mass power how much is there? 0. Therefore 0 by L power how much is there? Minus 1. So 0 by anything is 0. So like this they are going to ask. Next another one. They will give force dimension formula. M power x, L power y, T power z. What they said here? F is nothing but force. Find x plus y they will ask. Find x plus y in force. M power x, L power y, T power z. So whenever they said force, what is the force dimensional formula for us? Force dimension formula is, you people can say, we are saying repeatedly, you can think what is the force dimension formula? F is going to be M L power 1 T power minus 2. So in place of x how much is there here? 1. In place of y how much is there? 1. In place of z minus 2. So what is x plus y value? Now x plus y is 1 plus 1, that is 2. So what is y plus z value they will ask? Y plus z. What is y in force? 1. Z is 2. So 1 minus 2. So that is going to be minus 1. What is x by y they will ask? What is x by y means? X value 1, y value 1. Therefore 1 by 1. So like this also they are going to ask. So once you came to know the dimensional formula, you have to create question like this. We have, again I am saying, n number of dimensional formulas. Like this you can create so many questions, but we can't say that which one they are going to ask in exam. If you practice like this, whichever they are asking, if you know the dimensional formula, definitely you people can do whichever question they are going to ask. Next, see. So what is the ratio of dimension of length and time in universal gravitational constant? Now what is the dimension formula for universal gravitational constant? That is m power minus 1 L cube T power minus 2. If you forgot means, already we discussed this, in two ways we will get. G is equal to Gm by R square. So capital G is equal to small g R square by capital M. Small g acceleration, therefore Lt power minus 2 L square divided by M. So see, you will get same m power minus 1 L cube T power minus 2. They are asking dimension of length and time. Ratio of dimension of length and time. So length power how much is there? 3. Time power minus 2. So 3 is to minus 2. So same question they will ask. Universal gravitational constant capital G is going to be m power x, L power y, T power z. So what is x plus y? What is x plus y by y plus z? Like this. What is x into y by z? So their wish, how they are going to ask. If you create question like this, you will get idea how to solve the problem in exam. So m power x, L power y. X plus y means minus 1 plus 3. So minus 1 plus 3 means 2. x plus y by y plus z. What is x value now? X value is minus 1. Minus 1 plus 3 divided by 3, z value minus 2. 3 minus 1, 2. 3 minus 2, 1. This is 2 by 1. X into y by z. What is x value? Minus 1. What is y value? 3. Z value minus 2. Therefore, 3 is to 2. So next, x square by y. Another one, x square by y, x cube by y square. Like that, if you are solving the problems by enjoying, then definitely you people can get very easily all these questions. So you have to enjoy while solving the problems. Not only enjoy while watching TV, while watching movie, while going outside. You can enjoy by solving problems like this. This is by just knowing dimensional formulas. You have so many number of dimensional formulas, therefore you can create so many questions. So once you are creating all these type of questions, you do not require any materials. Material is nothing but provided by you people only. You can create your own material, you can keep your name for that material. Okay, so we will see with next class. So still more problems, more models, how they are going to ask from units and measurements or from dimensional formula. Thank you for watching.